Hello everyone, welcome back to the channel. So today I have another topic in number theory and on perfect squares, where we are saying that if n is a perfect square of a positive integer, and we've seen this many times in other videos, then if we express n as a product of a and b, then a and b are either both perfect squares, like n is a perfect square, so its two factors a and b have to be both perfect squares, or neither of them are perfect squares. So if a is a perfect square, then b has to be a perfect square, or the other way around. But if a is not a perfect square, then b cannot be a perfect square. Now these a and b, I'm not defining them as anything, they are just factors of n, where n is a perfect square. And we know that in number theory, a number can have various possible combinations of factors. So I'm going to start off with, firstly I'll rub this part because I need some space. Hope that's clear. I'm going to start with the usual definition of, not the first step of what we have been doing in my other videos that I'll link in the description. Wherever I had a perfect square of a positive integer, I wrote it as n is equals k square, where k is also a positive integer because k is the root of n, the square root basically, and since n is a positive integer and k has to be, we have seen this in many videos. I will link them. So, and then I'll do my favorite thing of taking some examples and say this is a perfect square. Now, why is it a perfect square? Is because if I take the root of n, then 1 to 1, 2. This can be written as 11 squared into 10 squared. Products are usually more convenient to write as dots, so I'll do that here. So then we can split the roots. You get 11 squared and 10 squared. So that's 11 into 10, that's 110. Well, that wasn't the point. 110 is root n. So root n is basically k. But I was saying that I need some kind of a and b here to be consistent with what I have here. So what are a and b here? If I factorize in this form, then it turns out that n is 1 to 1 double 0, because the root 110 is the root, and this turns out to be 11 squared and 10 squared, exactly how I had factorized here. I'm saying that a is this and b is this, and both are perfect squares. But if I write some other combination of factors, like a is this and b is this, then since a is not a perfect square, b is also not a perfect square, so neither of them are perfect squares. This was the second thing we said. The first thing we said is both are perfect squares. So for the same number, depending on the representation of a and b, you can have a product of two perfect squares, or if one term in the product is not a perfect square, the other one won't be a perfect square either. So now how am I gonna formally prove this? The elegant way of putting all of this together and getting there, getting to that conclusion of being pairwise perfect squares or being pairwise not perfect squares. So I will use a very powerful mathematical technique, and let me probably write this in red. It's called the principle of contradiction. Contradiction. Now, what we will do is in contradiction is we assume something and then we work out a few steps and we prove that our assumption was wrong for some reason. And that's a contradiction. So in this case, our assumption will be, this is not the, like, this is not the assumption for contradiction, this is just the assumption here. And it's not really an assumption, it's just a property of a perfect square. So the assumption here will be that A is a perfect square and B is not a perfect square. So A will be something like a p square, again, just like n, and then p will have to belong to, p will have to be a positive integer because A was a positive integer, because n is a positive integer. We are not considering the negative cases of like what if A and B are both negative and n is still positive. That is possible, but we are not going to get into that here. So A does have this representation, but B doesn't have this representation, unfortunately. No, it doesn't. Because that's our assumption that we are going to contradict. So, how are we going to contradict here? Let's work out a few steps. So, root of n, that is k, is root of a times b. And this can be written as root of p squared times b. And if I split the terms in the root, it's can be written as p squared. By the way, this splitting of square roots is for positive integers. For negative numbers inside the root, the laws are a bit different. So we are safe because everything is like positive integers here in this example. So this will be, this was p squared under root, so this will be just p times root b. Now unfortunately b is not a perfect square by assumption. So if it's not a perfect square, if I try to do this, k b. Now remember that k was a positive integer and p is a positive integer too. So the ratio of two positive integers will belong to the set of rational numbers q. Whereas on the right hand side, root of b, where b is not a perfect square, will be an irrational number. So it won't belong to the set of rational numbers. This is our contradiction. So on one side of the equality you have something that's rational, and on the other side you have something that's irrational. That's not possible. So that means for this to be rational, for root b to be rational, b has to be equal to something like a q squared. So b has to be a perfect square too. So that you will get root b is equal to root under root q squared is equal to q. And then you will have rationals on both sides. So what if A and B, both of them were not perfect squares? So now in this case, they were perfect squares from the assumption. That assumption for just one of them that I contradicted and proved that the other one has to be a perfect square too. But what if I had something that I done here, where both a and b are not perfect squares? So in that case, we'll have to remember that even if they are not perfect squares, I cannot, if I split the roots, I'll get irrational numbers again. But what we need to remember that is I wouldn't need to split the roots, because even if they are not perfect squares, they are still factors of n. They still represent this number when multiplied together. So they will represent n squared, sorry, k squared, because a times b represents n. So they will represent k squared. So you get k. You will get back a positive integer. But they are not perfect squares, they don't have to be. But if one of them is, then the other one has to be a perfect square too. So that's it. This is kind of important sometimes to remember this in some problems. This can be a small section of a bigger problem, and that's why I wanted to spend some time here. So thank you so much for watching this. Please subscribe to the channel if you find this useful, and as always, thanks so much for always being with me. Thanks a lot.